To begin with, use the graphing calculator to graph it. Should be in parametric, and then y equals the x value is tangent of t, and then the y value is secant. And the calculator doesn't have secant, so I'll need to use 1 divided by cosine. And then from 0 to 2 pi, secant and tangent can get fairly large, so I should change the x and y values, let's say from negative 10 to 10 and negative 10 to 10. And then take a look at the graph. And at first it looks like an x. But what's happening is the graphing calculator is not real bright, and it doesn't realize there's asymptotes here. The function itself is a hyperbola. So you can see it curving down just right there. Let me zoom in. So this is the function, this curve. This is the graphing calculator making a mistake, and this is the curve. So looks like it's crossing the y-axis at y equals 1 and negative 1, and then it's hyperbola. I just squished my little negative 1. Okay, then eliminate the parameter. Well, the equation for a hyperbola has x squared minus y squared or y squared minus x squared. With this being on the y-axis, it's going to be y squared minus x squared, and then it's equal to 1. And then each of these are over some number squared. And then that gives some hint as to what kind of algebra we should be doing over here. So square both of them and then subtract. So this one has y going first, so I'm going to do that. Y squared equals secant squared. X squared equals tangent squared. And then subtract them. So we would have y squared minus x squared equals secant squared minus tangent squared. And then how does that eliminate the trig? How does that eliminate the t? And we can also use the identity 1 plus tangent squared equals secant squared for whatever the argument t, x, theta. And we've got secant squared minus tangent squared, so if you do that, then secant squared subtract tangent squared is going to be equal to 1, which is perfect because that's what the algebra said we were going to get. So y squared minus x squared is equal to 1. That is a hyperbola.